everyone. I'm Summer Inman. I work for XD Innovations. This is our first podcast. We are a company, an engineering and manufacturing company, software company. We are a VAR for Dassault Systèmes. We work with Dassault Systèmes and partner with them to sell software, and we work with the high-tech industry. John Maculley is our guest today. He is a director of the global high-tech industry within Dassault Systèmes. So John, introduce yourself, please.
Hi, Summer. Thanks for having me. My name is John Maculley. I work, as Summer said, at Dassault Systèmes, and I work globally across the high-tech industry, and that includes semiconductors, humanoid robotics, AI factories, and other segments within high-tech. My primary expertise is in semiconductor industry. I spent nearly 20 years working in one of the largest semiconductor companies, primarily in research and development, and then also in operations of the company. And today in my role, I work with companies, with governments, and with academia on implementing best practices to improve the semiconductor ecosystem.
Thanks, John, for the introduction. We are very excited to have you. This is our first podcast, and we're very excited to have you. We will be talking about the semiconductor industry and IP governance and system readiness. You've got a lot of material that you've produced and you've published around that, and we really want to dive deep on the maturity of semiconductors and where we've come over the last 10, 15 years, and get your experience, and also talk about the Dassault Systèmes solutions that help in the maturity of semiconductors. And so let's start out by just talking about why now? Why are we talking about semiconductors? A little bit more about the industry and where it is today.
Yeah, so the semiconductor industry has been top of mind in everyone's news feeds and in conversations, and it kind of started with COVID, and all of a sudden people became aware that semiconductors are critical to their lifestyle, to their iPhones and their computers and their automobiles. And so, the misconception is that semiconductors are suddenly everywhere, but they've actually been everywhere for quite a long time. We're just now realizing how important they are to how we live our lives and the global economy in general. So they're a critical aspect of how the world works, and excited to talk more about that.
Yeah, thanks, John. Yeah, I was driving to work this morning, just thinking about this podcast. And I said, I picked up my phone, semiconductors. I'm driving in the car, semiconductors. So we don't think about everything that we do now has some kind of chip or semiconductor. And like you said, that COVID is in the absence of, or the issues that we had in getting those semiconductors. I remember trying to buy a car 6 years ago, and the car not being ready because the chip wasn't ready. And so all of that impacts our daily life. Talk a little bit more about maybe some of the geopolitical things and AI explosion as it's relating to what's going on in the semiconductor industry right now.
Yeah, sure. So you may have heard of semiconductor sovereignty, and it's a real thing. And countries have some critical elements that are required, to be sovereign. They need access to food, they need access to water, access to energy, and they are realizing and have realized that they also need access to semiconductor technology. It's critical to not only the devices and automobiles that their consumers use, but it's critical to their military infrastructure as well. And so the geopolitical dimension is quite relevant. You see in the headlines that there's various CHIPS Acts. In the U.S., there's the U.S. CHIPS Act, and in Europe, there is now the European CHIPS Act 2.0 is being moved through their approval process, and then there's investments from countries around the world, and it is driving the way countries rather spend their GDP to ensure that infrastructure is in place and they have a supply of semiconductor chips.
As you talk about supply and demand and supply and demand, there's the demand is just increasing significantly with AI and just consumer goods, all requiring chips and semiconductors. And with that demand increase and the supply just trying to keep up with that, there's a level of scalability there. So there's a gap that I read in the material, in your presentations and your material, the scalability gap that we have today. Talk a little bit more about that and what we're doing to try to fill that gap.
Mm-hmm. Yeah, well, there's definitely a supply constraint, and it's largely driven by AI, and AI is everywhere now. And what AI has done is it's unlocked the intelligence revolution. So similar to the Industrial Revolution that we've all read about and maybe lived through parts of it, we're now in the intelligence revolution, and it's reshaping global economies. And so, with that proliferation of AI, there's also infrastructure that's required to make that work, and there's semiconductors that are underpinning all of it. So there is a complexity wall, and what's happening is the complexity to make these systems work is increasing at a faster rate than the engineers can, productively keep up with. So an interesting thing has happened. The industry has shifted from Moore's law to Jensen's law, and this is Jensen from NVIDIA, of course. And with Moore's law, the idea was to shrink the die to smaller levels to make computation cheaper. And we're now scaling intelligence with infrastructure. So it's like the inverse of Moore's law. That's really driving a lot of complexity. So the AI factory is now the chip, if you will, and this is now the focus of optimization. And this is where Dassault Systèmes is really taking a leadership role with model-based systems engineering, where we are world-class leaders in that space. Growing up, the company has grown up in aerospace and automotive, where model-based systems engineering is kind of the way you do things. It's new to the semiconductor industry, and we're now driving this, and we're spearheading it with our partnership with NVIDIA as well.
And as you talk through model-based system engineering and IP specifically, and what Dassault is doing around the maturity of managing the IP is one piece, but then from a maturity standpoint, really working through that IP strategy as it relates to semiconductors. So walk us through what that looks like, both from a maturity level, but also Dassault solutions around that. Yeah,
so there's different levels of IP maturity within companies, and I guess just to back up, why is it important to think about IP and manage IP? IP is really the value that a company produces. When innovation is codified, it basically becomes intellectual property, and so it's critical for companies to manage that, to reuse it, to govern it, and ultimately make it available, across their organizations, so it can be utilized. And so, we have an IP maturity model that Dassault Systems has put together. There's various levels where we assess our customers' maturity level. And it starts with level 1, which is just plain generation of IP. And it moves through the various phases, ultimately reaching level 5, which is where you have achieved collective intelligence. And that's really where AI can take advantage of the IP and move a company forward.
So how many companies do you think, if you're looking at that maturity model, specifically around IP, where do you think most companies live in this space as far as their maturity?
Mm-hmm. Yeah, surprisingly, companies are still at the beginning stages of the maturity journey, and all of them are very good at generating IP. And most of them have figured out how to manage the IP that they have. They're moving into level 3, which is IP reuse, and that is a little bit more difficult problem to solve. But that's kind of where we see companies right now, kind of at the level 2 management and working hard to increase their reuse percentage.
And that's interesting, because I would think that maybe where we are in the learning curve or the maturity curve, more companies would be higher. But I mean, I can see we are more at the level 3. What is the benefit of increasing in that maturity level? What benefit does a company have for their IP and for their company and that as well?
Yeah, well, it's a scaling benefit, but if we just take reuse in particular, Dassault Systems has a fantastic tool that's widely used. It's called Design Sync, and it's based on our Innovia brand. And we now have just introduced this year next generation Design Sync. Basically, it's called Semiconductor Engineer, and it is an important tool that our customers are using, because it serves as an orchestration layer. And if you look at the way companies currently generate their IP and even manage their IP, it's done in kind of a dispersed manner. There's many different tools and many different organizations that are generating the IP, and those tools don't always talk to each other. In fact, they typically don't. And so what Dassault Systems does is we bring in an orchestration layer. We don't replace the EDA tools or other tools that are generating IP. We simply orchestrate the IP to help companies reuse it and then enable it for AI.
No, that's interesting. So a little bit more about Design Sync, and just so we can explore it a little further, does it allow for repeatable processes? So you're not just creating and letting it sit on the shelf, for lack of a better term, or recreating something. How does Design Sync really help the organization in with the engineers on the ground floor?
Yeah, so surprisingly, most companies today, even the ones that you would think of as leading edge, are still very siloed. And so the different disciplines, they have their favorite tool, and there's multiple EDA tools that are typically used across a company. And so what Design Sync does is it brings the IP into a shareable repository. And it ensures through business processes that IP is verified and validated and can be reused. And so one of the biggest struggles that engineers run into when they're looking at a new product design is they don't have an easy way to search IP repositories and to even know what IP is available. And what Design Sync or what we're calling Semiconductor Engineer, what that enables engineers to do is easily identify the IP. And it's more than just semantic search, which has been typically used in the past. It's kind of next level search capabilities and using AI to identify IP based on the requirements of the product itself. So that's a real game changer in the industry.
It seems like it would make things more efficient and really save time with the collaboration across different engineering teams. Is that one of the benefits?
Yeah, absolutely, it's a benefit. By implementing this type of system, you're basically crossing all of the silos. So it's the silos are often driven by organizational design. And so it's tough for one single organization to break down a silo. It really needs to be a top-down kind of mandate. And so what Dassault's products do is it implements this orchestration layer that really crosses all of the silos. And what it's doing at a macro level is it's democratizing IP, and it's really making all of the IP that's being generated across a company accessible at whatever point the product is being developed and whichever group an engineer happens to reside in.
I've heard of some stories where there's been a loss of obviously time, but inaccuracies and product as well. Does this help? Does Design Sync help with going back and fixing inaccuracies and issues with the semiconductors and the IP? Does it help with that as well?
It's part of the solution. There's obviously a lot more to developing semiconductor products than just the IP. But when you combine Dassault Systèmes semiconductor engineer Design Sync tool with other tools that we offer, and all of this is built off of what we call the 3D Experience platform, which is just an end-to-end platform that really serves as this orchestration layer. One of the unique things about Dassault Systèmes is all of our products, all of the brands that you might be familiar with, like Katia and Simulia and Delmia, they're all fully integrated in this 3D Experience platform. And so that's a key differentiator for us in the market. And it definitely helps engineers because when they identify perhaps downstream that a product is not performing as it should and they need to modify some IP, they can rely on this repository, and it's been validated and it's ready for reuse, so they don't have to create new IP or reinvent the wheel over and over.
So it sounds like it's, like you said, there's an integration there with 3DX, but a repository, a data repository as well, which is a key fundamental piece of the 3DX platform, and using these systems together. That's what some of the things that I'm hearing you say. And some of our customers have experienced that as well with the platform and how easy it is for data sharing and data modeling. Maybe you can elaborate on some of that as well.
Yeah, so the 3D Experience platform, obviously is what we believe is an essential tool that companies need to orchestrate across their various tools and to create this IP repository to improve reuse. But more importantly, I think, even beyond IP, what it serves as is, what we call a company's corpus of knowledge and know-how. And that becomes the foundation for agentic AI. So now we're kind of getting into the next level strategy beyond simply IP management. But through IP, what companies are doing now is they're codifying their knowledge and know-how on the 3D Experience platform, and that knowledge and know-how can be used to fine-tune foundation models, basically. And so instead of deploying agentic AI using standard models that are, that use public information to produce results, companies are plugging their models into these repositories, and they now have a proprietary data set. And so it gives them a competitive advantage in the marketplace.
That's I can imagine how that would continue to help with the collaboration as well as speed up the process. Yeah, going back to supply and demand, and as much time as you can cut out of the process and reuse what you have, the more AI is speeding things up and helping us get there. And the semiconductor industry is no different. And so that's some of the things that I'm hearing from you, which is important. So I'd like to, maybe on the design sync piece, is just deep dive a little bit more around the security enforcement and maybe the IP synchronization, maybe looking into that and some of the governance around that. So John, from a macro level, as we're looking at IP synchronization and integration, how does that tie back to AI and and data centers and big data? So let's talk about that piece of it from a macro level.
Yeah, that's a great question. So, Dassault Systems has recently partnered with NVIDIA, and you may have seen the announcement at the beginning of this year. And we've been selected by NVIDIA to build out, using model-based systems engineering, their AI factory infrastructure. And NVIDIA selected Dassault Systems because we are world-class in systems engineering. And so through our CATIA MBSE solution, we are connecting semiconductors all the way through to AI factories. So chips to infrastructure is our the journey that we're on. And so we're working across the ecosystem at both ends with the with the actual device designers and manufacturers, all the way through to the companies that are producing the power and cooling infrastructure. And the 3D Experience platform enables that end-to-end connectivity and traceability. And so when you combine model-based systems engineering with our Inovia tool for BOM bill of material configuration and IP management, which is also delivered through Inovia via Design Sync, you really get a powerful solution that enables companies to build their and design, build, and test their products within the context of the end product, which in many cases now is the AI factory.
So what does that look like for companies as far as the speed in which they can deliver compared to what they had before?
Yeah, so we target the projects that we work on at a strategic level. One of the criteria we look at is, does it produce a 10x improvement in how things are currently done? And so that's kind of a threshold for us. And 10x is huge, right? And 10x in terms of time to market can take activities that take months down to weeks. And in terms of dollar savings, it's obviously millions of dollars, and depending on the scale of a company, it could be billions of dollars. So that's the magnitude of the impact that Dassault Systems is making across the high-tech industry, and specifically with AI factories, and that chips to infrastructure value chain is where we're having a big impact.
Mm-hmm. And it makes a huge difference. And also I read in some of the material, doing some research, is that you can look at the automotive industry as well. There's semiconductors and chips are highly involved in the manufacturing of a car and the automotive industry. And it could, not having those chips ready or not having that manufacturer, that design, or pushing all the way through the process, could be a 9 to 12 month delay in getting a new technology and a new product out to the market, to the consumers. And I see this, and I've read that Dassault Systems and the products and the technology we talked about helps increase or mitigate against that 9 to 12 months for that to align with the release of new products to consumers. So in the automotive industry as well is a big piece of where the products are being used to help.
Yeah, the automotive industry is a huge consumer of semiconductors. I think about 20% of semiconductor sales goes to automotive. It's critical for autonomous driving, and so the use of semiconductors within cars, whether it's for ADAS systems or in the dashboard, you know, all the electronics that go into an automobile now. You know, a lot of people think of cars now as basically computers with wheels. So it takes a lot of compute to make those work. And that's where Dassault Systems, one of the areas we really shine. All of the top automotive companies use Dassault Systems to design and test and manufacture their automobiles. And so we, through our virtual twins, we're able to create or rather enable system technology co-optimization, or STCO. So semiconductor companies can design their products in parallel with the design of automobiles, and they can test them in a virtual way. And so it's no longer a serial process. We're able to enable that ecosystem to work in parallel. So it significantly reduces time to market for both the, you know, primarily the automotive makers, but it enables the semiconductor companies to design a better product and have it ready at the right time.
And that brings us full circle back to the initial conversation we have, is that we can't do anything now from a consumer or even, you know, in a business environment without touching some kind of chip or semiconductor. So we talk about it as high tech, but really it's integrated in all of the industries and all of the products that we use. So that's full circle here on what we started talking about initially, actually. And it does cut time, and it really does help keep everybody, as we said, truly working together on a platform and synchronizing the data at the same time.
Yeah, absolutely. So just to add to that, you know, model-based systems engineering is not new. You know, other industries, primarily automotive and aerospace, have been using MBSE for decades, and that's one of the reasons they've become so successful. But it's new to the semiconductor industry, surprisingly. And so we're now seeing huge benefits by implementing MBSE. Again, I go back to the NVIDIA partnership. Even companies as successful as NVIDIA is are new to model-based systems engineering. So this is a new journey that they're on, and we are happy to work with all of our customers across the high-tech industry to introduce them to the power of MBSE, and that's primarily driven by our CATIA brand, and then in combination with Innovia, and then all of that on the 3D Experience platform. So it's a full solution, and it's really driving the industry right now.
And what we're seeing at XT Innovation and some of our customers is partnering with their suppliers, and they have an environment where they're developing, and their suppliers are coming in obviously to the environment as well, and you can see that through MBSE of what they're developing through through CATIA and through the platform, and how that plugs in, and you can see it interact together. And I think that's what's so important with high tech, is that yes, it's an industry, but it's an industry that plugs into other industries, and be able to have that MBSE and see that together is really the power of the platform.
Yeah, absolutely. Being able to design your semiconductor products, in the context of the end product, is absolutely critical, and you're able to test it virtually, and optimize it, and make sure that it's performing in a way that maximizes ultimately the performance of the end product. So it's a win-win for everybody.
Mm-hmm. We have a couple of customers at XT Innovation that had been working in the platform and working with MBSE, and then they brought simulation into that as well. So they are high-tech companies that are bringing simulation into that, and bringing their semiconductor suppliers into that as well. So it's interesting to see all of this come together to the end product of the car, or the battery pack, or the different components of high tech coming in with transportation and mobility, and automation and other industries together. So it's one blur, and what's bringing it together are the chips.
Yeah, chips are certainly foundational, and you bring up simulation. Simulation is really the core activity of the semiconductor industry. It's absolutely critical, and there's different types of simulation. When we talk about model-based systems engineering, what we do with that is a one-dimensional simulation. It's based on SysML, and so it's a very high-level architectural view of making sure that different components work together at the system level, to make sure that you are achieving the system intent. But then that's at the front end of the process, and then as you go downstream and you start engineering these different components that are going to make up the system, you really get into multi-physics simulation, and that's where Dassault Systèmes' Simulia suite of tools make a big difference. And so everything from simulating radio frequency for antennas, like in our phones, or drop testing of the phone to make sure that it can withstand that impact. And then also, multi-physics simulation. So at the semiconductor level, there's a lot of heat that's generated. So we need to understand how that heat is propagated, if anything is going to warp or cause stress fractures that will, decrease the usefulness of the semiconductor chip. And even into in computational fluid dynamics, when we're looking at how liquid cooling can help in an AI factory or within a rack itself. So all of this type of simulation is absolutely critical. And so not only are we enabling engineers to utilize our tools to do this simulation, but we're now enabling AI agents to do this. And so through agentic AI, the agents can simulate and can do generative engineering. So they can create parts that have been optimized through AI, and engineers now can serve as kind of a validator and a governance layer of what AI is producing.
So we're training these agents with every click that we make.
Yeah, well, AI is all around us, and It's not a negative thing. It's actually a
Yeah,
very positive thing, because
yeah.
all of this information that we learn throughout our careers, um, and a lot of it is tribal knowledge, believe it or not, that's not documented anywhere. And so if companies can get that tribal knowledge codified and put into a database that can be accessed by AI, it now can be shared across the company. And so again, getting back to democratizing information and ultimately achieving collective intelligence. I mean, that's really where Dassault Systems tools play a big part, because it's a critical layer to transfer that tribal knowledge into information that can be shared and utilized by AI.
And I hear what you're saying, and I also have seen it, experiencing it with some of our customers. At XD Innovation, we have multiple startup companies, and they have been able to, by using these tools, by using simulation tools, by using 3DX, they've been able to cut their cycle time in half and get their product to the market quicker. And those are companies that use semiconductors in their product. And so it's been very interesting to see how our customers are using these tools to help them continue to learn, to teach the system, to really teach the system through AI to be able to get their products out quicker. That's what I was trying to get out. It's been to see the evolution of it, to see the evolution of the Dassault Systems products, to see how customers in the high-tech industry are really starting to use it, as you said, from a maturity standpoint, catching up with the other industries and partnering with them. And that ties all of it back together, really high-tech, semiconductors, and all the other industries together with Dassault Systems products.
Yeah, Dassault Systems is an amazing company. It's very visionary, and if you look at the history of Dassault, started over 40 years ago with just simple component CAD, and it's evolved, and it's created product lifecycle management. So PLM was coined by Dassault Systems, and over the journey, it's continuously attacked the next big problem that the world is facing. And so right now we've entered our 7th generation of Dassault Systems vision, and it's all around 3D universes. And so the semiconductor industry, or high-tech industry, and basically all industries fit into this model where they have their 3D universe, if you will, which is a physics-based corpus of knowledge and know-how around how that industry works. And so when you take semiconductor companies, for an example, they can design their products within these pre-configured and intelligent 3D universes, and see how their products are going to perform, how they can be manufactured. They can simulate that manufacturing process, and they can optimize all of their designs early, obviously improving time, quality, and cost. So that's kind of the underpinning premise of where Dassault Systems is moving the industry forward.
And that's the roadmap. I mean, to also add to that and summarize it, that's the roadmap we've been talking about throughout the entire podcast, is that roadmap. Some of the final stages of the roadmap is, you're talking about Gen 7 and going in that direction as it relates to semiconductors and that roadmap, and taking the Dassault Systems product and Design Sync and Innovia and CATIA and 3DX and pulling that all together. what semiconductor companies do you think, and you don't have to name the names, but maybe you do, what semiconductors do you think is closest to that roadmap vision, and what are they doing differently, and how are they differentiating themselves?
Yeah, obviously I won't name names, but there's a lot of great semiconductor companies out there, and just, based on the complexity of the product, semiconductor companies typically hire the smartest people around the world, and so they're solving the most complex problems. But they're very focused on their domain specific activities, and they're primarily, made up of PhDs that love engineering, and so there's less people in semiconductor companies that are focused kind of on these these operational, how can we get things to work more efficiently, solving those types of problems. And so we're finding that semiconductor companies are welcoming Dassault Systèmes 3D Experience platform, because it's just a very easy, tool agnostic orchestration layer that, it's not a rip and replace story. It's one where, the engineers keep using the tools that they love and know how to use, and we become a complement to that, that software stack. And so that's really changing the semiconductor industry, and we're seeing a huge adoption of the platform approach. And once that's in place, they can then start enjoying the vision of agentic AI and all of the other things that Dassault brings to the table.
And that helps a VP of engineering and those semiconductor companies. If I don't want to put you on the spot here, but if you were a VP of engineering listening right now and one of these semiconductor companies, and they want to do better. They see where they are from a maturity level. They want to get to the next level. They want to realize the time savings, the cost savings that we talked about, the speed to production. What do you think they should do? What are their next steps? What do you think they should do listening to this this quarter to improve?
Yeah, I think obviously there's a lot that they can do, but fundamentally they need to democratize the knowledge and know-how in their company, and they need to think in terms of ecosystems. Not only is there an ecosystem within their company, so there's different disciplines and organizations that need to work together, but there's also an ecosystem across the value chain. And so, the biggest recommendation I give to my customers is, implement an orchestration layer, preferably Dassault Systèmes 3D Experience platform, and use that as the foundation for starting to explore some of these different capabilities that we offer, whether it's IP management, through Design Sync, or whether it's model-based systems engineering through CATIA, or virtual twins also through CATIA, and then simulating those virtual twins with Simulia, and even improving your manufacturing processes with Delmia. We have a whole suite of tools, more than I've mentioned here, that can be a real game changer for these companies. So the advice I gave is start with the platform, and then start experimenting and finding what capabilities are solving your most important problems.
We didn't even talk about EBOM to MBOM, did we? There's so much we could talk about. Maybe that's our next episode, EBOM to MBOM.
Yeah, we could talk for days. Dassault has quite a bit that it brings to the market, but absolutely, EBOM to MBOM is another big conversation. We can save that for another time.
Well, this has been great, John. I really appreciate your time. I'm looking forward to doing more of these. We'll get some feedback and see what everybody wants to hear. This is very relevant of what we're trying to do right now and communicate to our existing customers and potential customers. And really, we want to help them get to market quicker. We want to help them collaborate more. We want to help them in their maturity journey and their roadmaps. And they can definitely reach out to us, and we can have some conversations.
Yeah, that's great. Happy to help, and excited to support your company, and obviously help both of our customers take advantage of all of the great tools Dassault Systems brings to the market.
Exactly. Thanks, John. Really appreciate your time and your help here. We're looking forward to having more. This is the first of many.
Thank you, Summer. Thanks for your time.
Thanks.